In this lesson, we're going to explore the physical security control measures known as door locks. Now, all of your perimeter physical security defenses that you're going to be using to protect your organization's facilities are going to become useless at some point. Do you know when that point is? Well, it's the moment that somebody has entered your building. That's right. We can install a large electrified fence with barbed wire across the top. We can install large steel or cement bollards outside our offices to keep cars from getting too close to the building. We can install surveillance cameras around the perimeter and throughout our parking lots. We can have roving security guards with guns walking around the perimeter of the building. We can install access control vestibules at the entry point of our buildings. And we can even place armed security guards in our lobby. But once that person crosses through our lobby and is able to access our secure spaces, they are now roaming freely through our halls and looking for areas that they can exploit inside of our organizations to access our sensitive data. So, how do we keep people out of those offices that contain sensitive information? Well, quite simply, we use door locks. Now, door locks are physical security controls that are designed to secure entryways by restricting and regulating access to a particular space or property. These door locks can act as a primary barrier against unauthorized intrusions to ensure that only individuals with the appropriate key, code, or access method can open the lock and gain entry. These door locks really do play a foundational role in safeguarding your digital assets, information, and individuals from potential threats or unauthorized access. Now, these door locks are often placed on the outside of the building's main entrance, as well as inside the building on different server room doors, network closets, and other areas we want to remain safe and secure. Unfortunately, though, not all door locks are created equal, and some are going to offer us higher levels of protection than others. For example, I've seen many people who use a simple padlock to try to secure their network closet that contains sensitive equipment like routers and switches, or to secure a filing cabinet that contains classified or proprietary information. The problem is that a skilled attacker can defeat a padlock in about 15 seconds or less. Don't believe me? Let me prove it to you right now. So to do this demonstration, we're going to use four things. I have a standard padlock. I have the keys for that padlock. I have a lock pick. In this case, it is a single lock pick that will have one single tooth that will try to move the pins up and down. And I have a tension wrench. So first I'll show you that the standard padlock, you can see this is see-through so you can actually see inside of it. We're going to put the key in, just like we normally would. We will open it, and you can see it's just a standard lock. It opens to the right, and if we take the key out, we can lock it again. So now what we're going to do is we're going to take the tension wrench, and we're going to place it into the keyhole at the bottom. Now, when we go to open the lock, we want to be able to turn it to the right. So I'm going to constantly apply just a little bit of pressure with my pinky to hold that in place. And then I'm going to use the lock pick, and I'm going to pick each of those 6 pins to find the right place for them. And once we get them right, the lock will open. You can see just how quickly and easily it is to be able to pick a lock in this manner. All right, so as you can probably guess by now, I'm not a big fan of padlocks because they are not very good for our security. These padlocks use a basic pin and tumbler system that is really easy to defeat if you know what you're doing. But many door locks simply aren't much better, because most door locks, like the one on your bedroom or bathroom door, you can simply defeat that by sticking a long and slender rod or needle into that hole, and it will simply pop open. If you have a lock with a flat slot on it, then you can actually use a flathead screwdriver or a coin from your pocket to unlock those simple door locks. But most of us are going to use a more complicated door lock like the one on the front of your house. And if you look at that one, it uses a traditional key to lock and unlock the door. Well, these are a little bit more complicated than a standard padlock, but they can still be defeated using the same techniques in about 30 to 60 seconds by most skilled attackers. Thankfully, though, more complex types of door locks are also available to us. And many of the door locks on the markets these days use electronic mechanisms to provide better protection, such as using an identification number, a wireless signal, or some kind of biometric to unlock or lock that door. Now, one of the most commonly used electronic door locks you're going to find is ones that rely on an identification number. For example, at my recording studio, we have an electronic door lock that uses an 8-digit personal identification number to allow our instructors to go into or out of our studios. Since it uses an 8-digit number, there's a 1 in 100 million chance that somebody could randomly guess my identification number. Also, these locks can also be configured so that each person is using their own unique identification number to access our studio. This way, we can actually log all of that access into our entry log as a form of auditing and accounting so we know who is in the studio and at what time. Another commonly used technology with door locks is wireless signals. For example, at my home, I can open my front door using my smartphone by tapping it to the front door to unlock it and sending out a NFC or near-field communication signal, and the door will then unlock based on the fact that I have my smartphone. Alternatively, I also have seen locks that use Wi-Fi, Bluetooth, and RFID to be able to lock or unlock your doors. Another commonly used form of authentication with modern door locks is the use of biometrics like facial recognition scans or fingerprint identification scans. In fact, my server room door here at the offices actually uses a biometric lock that allows me to lock or unlock that door simply using my index finger. Similarly to a personal identification number, we can also configure this lock to use each person's own fingerprint, and then each entry or exit is logged for accounting and auditing purposes based on that fingerprint. Now, biometrics relies on your physical characteristics to identify a person properly, and this is most commonly done using something like a fingerprint, scanning the retina inside of your eye, or by measuring the distance between different parts of your face when conducting a facial recognition scan. All of these are considered to be an inherence factor or something you are in terms of the 5 factors of authentication. Now, when we talk about biometrics, what we're really focusing on here is that something you are, because this is the part of you. It's your eye, it's your fingerprint, it's your voice. It's something that is innately a part of your ability and part of you as a person. Now, when we talk about fingerprints have become a really common identification system. And at this point, it's gone beyond door locks, and now it's integrated into most of our smartphones, tablets, and laptops as well for us to be able to log into our devices. For example, if you have an iPhone that's between a 5S model all the way up through the 8 series, those used a thumbprint login called Touch ID. Whenever you press your index finger or your thumb to the sensor, it's going to be able to read that and then identify you and log you in. Now, in newer iPhones, though, they've done away with Touch ID, and instead they're now using Face ID. So, if you have an iPhone 10 or newer, they actually have a front-facing camera that will scan your face and measure the distance between different areas of your face to uniquely identify you. This allows you to just hold up the phone in front of you and then log you in automatically by identifying that it is you who's holding that particular phone. Now, these types of devices are also being integrated into our door locks and physical access control systems too, like our access control vestibules. I used to work in one high security area where every day I had to use a retinal scanner to gain access to that facility. I've also worked in places that simply used a fingerprint or a pin that allowed me to get through that access control vestibule. It really does depend on how your system wants to be set up and how much security your organization needs based on the information it's trying to protect. Now, when it comes to biometrics, we do have a couple of challenges that we need to focus on, and namely, this comes down to the acceptance and rejection rates. Obviously, since we're using biometrics as a form of authentication, we should be worried about its false acceptance rate. The false acceptance rate, also known as the FAR or FAR, is the rate that the system authenticates a user as valid, even though that person should not have been granted access to the system. For example, if you walked up to the fingerprint reader, placed your finger on it, and it accepts you because the system thought you were me, that would be considered a false acceptance. To prevent unauthorized people from entering the building or using our systems, we want to ideally get that false acceptance rate down to 0 by increasing the sensitivity of our scanners. Now, on the other side of the spectrum, we also have a false rejection. Now, a lot of people think that a false rejection is not a problem, but this is actually just as big of a problem for us as a false acceptance. Let's go back to that last example. Let's say I increase the sensitivity of the fingerprint scanner to attempt to eliminate all of the false acceptance rates, or FAR, that we were getting, so that way I can make sure nobody's getting in the system except those who are authorized to do it. The problem with this is that I may inadvertently also increase my false rejection rate, or FRR, because the scanner is now too sensitive. A false rejection is going to occur anytime the biometric system denies a user who should have been allowed access to the system. So, using the login with the finger as an example, let's assume you're able to log in as me using your fingerprint. Now, I increase the sensitivity up to the highest level. Now, when you try to log in, it's going to reject you, and there are no more false acceptances happening. But about half the time when I try to log in, I am also being rejected, even though I'm supposed to be authorized. Now, this is the idea of a false rejection, and why it's also considered to be a big problem for us, because it's failing to allow me to authenticate half of the time, which means half of the time I can't get into the building to do my job. So, how can I perfectly tune the system to eliminate the false acceptance and the false rejections? Well, we try to achieve a good balance between these by where we find the false acceptance rate and the false rejection rate becoming equal. This equal point is known as the equal error rate, or EER, but most commonly, you'll hear people call this the crossover error rate, or CER, out in the cybersecurity industry. This is because your false acceptance rate and your false rejection rate are intersecting at that specific point where they're equal, which is the crossover error rate. This crossover error rate is really important because it's used as a measure as the effectiveness of a given biometric system. So if you're going out there and looking to purchase a fingerprint-enabled lock, you want to make sure you're checking what is the crossover error rate. and you can use this as a factor in your decision making. The lower the crossover error rate, the better that lock is going to be. You don't want one that has a huge error to the positive side or the negative side. Instead, we want to have a good crossover error rate so that we are letting the people in that are supposed to be authenticated and rejecting those who should not be allowed into our system. Now, many of these modern electronic door locks will also combine multiple authentication factors to give you additional security to be able to protect that area. For example, my server room door can be configured to use an 8-digit personal identification number and your fingerprint together as a multi-factor authentication system before you're allowed into that room. For more complex setups, such as trying to gain entry to your office building through an access control vestibule that uses an electronic access system, you'll also find that some of these are going to be fully automated using an electronic badge and PIN system to validate the person's authorization to go into that building. So you may find that as you enter into an office building, there's an open lobby that anybody can access. But then there's a set of turnstiles, and you'll have to scan your badge and input your PIN number to be able to go past those turnstiles. That area between the front door and the turnstiles, well, that's considered an access control vestibule under the design of that particular lobby. Once you get past those turnstiles, you're now in the secure area because you've now been authenticated using multi-factor authentication by having a token, your identification badge, and a PIN that you entered in, which is something you have and something you know. Now, the final type of door lock you should be aware of is an older type of lock known as a cipher lock. A cipher lock provides excellent protection using a mechanical locking mechanism with push buttons that are numbered and require a person to enter the correct combination in order to open that door. These are often used on server rooms, network closets, and other high security locations. They do tend to cost a little bit more than a traditional office lock, but they do have the ability to give you a higher level of protection too. In fact, the Dion Training Offices uses a mechanical cipher lock on our front door to our building, and it requires that you enter an 8-digit identification number in order to unlock our door. Now remember, door locks are an important physical security control measure that you're going to be able to use to protect your sensitive data and systems out in the real world. While organizations invest heavily in external security measures, such as electrified fences, surveillance cameras, and security personnel, the actual moment of vulnerability arises when unauthorized individuals gain access to the building's interior. Door locks can serve as a primary defense mechanism to restrict unauthorized access to your most sensitive of spaces. However, not all door locks offer the same protection levels. Traditional padlocks and basic door locks can easily be defeated in about 60 seconds or less, whereas modern electronic door locks, which rely on identification numbers, wireless signals, or biometrics, can offer more robust forms of security. The effectiveness of the biometric systems is measured by their false acceptance rate and the false rejection rate, and you should aim for a balanced crossover error rate to achieve the best mix of security and convenience for your organization when using a biometric-powered lock. The combination of multiple authentication factors, such as using a fingerprint and a PIN, or an access card and a PIN, can also increase your physical security posture. We also talked about various types of door locks, including mechanical cipher locks, sophisticated vestibule systems, and other forms of electronic door locks that authenticate individuals before granting them access to your secure areas to better protect your data.